We have our data classes created and are now able to remove our choices. This means that we are finally ready to start saving our graph. Of course, if you haven't yet created the necessary classes for it, make sure you watch that part first. Before we go ahead and start making our saving system, it's better for us to first understand how is it going to work. We have already talked on how the data is going to turn into files and folders. What we need to know now is how are we going to iterate to the necessary graph elements in a way that we can save them into those files and folders. In our final folder structure, there will be static and dynamic folders. Static folders are those folders that will always exist regardless of the graph elements. Such is the case of the global and the groups folder. Dynamic folders are those folders that will depend on the graph elements. In this case, it will be a folder for each group in the graph, as they will likely have different names throughout the different graphs. So we'll start our save system by creating those static folders. With the folders created, we can then focus on getting the elements from the graph and separate them into a nodes and groups list, as that's all we are going to need to be able to save. With our elements in their respective lists, we'll be able to start saving them. To do that, we'll of course need to first create our graphScriptableObject, which will hold all the necessary data to both save and load the graph, as well as our Dialog containerScriptableObject, which will hold all the necessary data to create our custom inspector later on. We'll need to save both our groups and our nodes to these two scriptable objects. So with those assets created, we will then start by saving our groups first. They'll be saved to the GraphSO, the ContainerSO, and to their corresponding folders and files. After saving our groups, we'll have to save our nodes. They will be saved to the GraphSO, the ContainerSO, and their corresponding files. When we finish saving our nodes, we'll actually need to update them again to be able to update their connections. We'll talk about on why we need to do that only after we save the nodes when we get there. After all of our groups and nodes are saved, and both the graph and the ContainerScriptableObjects have their data updated, we'll need to finalize the system by removing the unused group and node files and folders from our project. That's the base of our saving system. And to be able to do all of this, we'll be creating our own utility class. So in Unity, in our Dialog System Editor folder, go to the Utilities folder and create a new file to which I'll name DSIOUtility. IO stands for input and output, as this class will be used to both save and load our graph. Inside, feel free to remove the default methods as well as monobehavior inheritance. I'll make it part of the utility subnamespace. Much like our other utility classes, I'll make this class be static. We'll start by creating our save method. So type in public static void save. I'll make this method be part of a region named SaveMethods. The first thing we need to do is to create our static folders. We'll need to create them in two different places. The editor folder, in which we'll be creating a graph folder for our graphScriptableObject, and the non-editor dialog system folder, in which we'll have multiple static folders. So call in a new method to which I'll name CreateStaticFolders. You can name it default or something else if you prefer. I'll make it part of a new region named CreationMethods. To create our folders, we'll be using a method named createFolder from the Unity Asset Database class. This method simply accepts the path of where we want to create the folder in, as well as the name of the folder we want to create. However, it does require that every folder of the path we pass in already exists, so for that particular reason we'll need to make sure we create the previous folders as well. The only thing we need to keep in mind is that we don't really want to create a folder that already exists. Thankfully, the same asset database class also provides a method named isValidFolder, which, as the name states, it tells us if a folder with a given name already exists. So start the method by typing in if asset database, and we'll need to import the Unity editor namespace. Then, back to our if statement, type in .isValidFolder. You'll first be creating our editor graph folder, but because our system already comes in the assets editor default system folder, as it won't work otherwise, we'll only need to care about checking for the graphs folder. So type in assets @editor @dialog system @graphs. You can check for the dialog system folder as well if you prefer that, but I'll assume my system is always in this folder. Do note that we shall not type in a slash at the end of the path, as otherwise the method will count it as an invalid folder. Inside the if statement, simply return, as we don't want to create it again if it already exists. Under our if statement, we'll create the folder by typing in assetDatabase.createFolder. Under the first argument, we'll pass in assets @editor @dialog system, again without the slash at the end, and then graphs as a second parameter for the name of the folder. We'll be wanting to do this for multiple folders, so we should create a method for us to call this code multiple times. So select the code, and if you are in Visual Studio, simply press Alt Enter and choose Extract Method. I'll name the method CreateFolder. I'll make it part of a new region named Utility Methods. The method we've created automatically did not create parameters for us, so we need to make sure we add in a string parameter, to which I'll name path, and a second parameter of type string as well, to which I'll name folder name. Next, copy the asset database.createFolder strings and pass them into our own createFolder method call. When that's done, back to the asset database.createFolder method, make sure it uses our new parameters instead. We'll need to do the same for our isValidFolder, so make it an interpolated string, in which you can do it by adding a $sign before the string, and then swap its contents with path between curly brackets, which makes the string get a variable value, and then add a slash and folder name between curly brackets as well. With that done, we can now reuse the method to create as many folders as we want. So back to our CreateStaticFolders method, we'll create our non-editor folders by typing in CreateFolder at the path of assets and with the folder name of dialog system. We are now saved to create our dialogs folder, so type in CreateFolder at the path of assets at dialog system and then dialogs for the folder name. Every non-editor folder will be inside of this dialogs folder. This folder was simply created for organization purposes. What we need to do next is to create our graphFileName folder. However, we don't really have a way to know the graphFileName here, as it is written in our toolbar FileName text field. Because we'll be calling the save method whenever we press on the save button, we can simply create an initialization method that gets called before we save. So above our save method, create a new public static method to which I'll name Initialize. As a parameter, we'll be accepting a string to which I'll name graphName. Of course, to save this name somewhere, we'll need to create a global variable. So above, create a new private static variable of type string, and I'll name it graphFileName. Then, simply assign the value of graphName into this variable in our Initialize method. As we start creating and saving files, we'll need to always type in the full folder path, which will almost always be our non-editor folder path. So to help us out with that, we'll be creating a variable that will hold that non-editor folder path, so that we don't need to type it in every time we need it. So create a new private static string, and I'll name it containerFolderPath. I simply named it container because our main runtime part scriptable object is named Dialog Container. With a variable created in our Initialize method, type in containerFolderPath equals to a new interpolated string with a path of assets@dialogsystem@dialogs@graphFileName between curly brackets. We now have the containerFolderPath and the graphFileName, so back to our CreateStaticFolders method, we'll create our graphFileName folder by typing in CreateFolder as a path of assets@dialogsystem@dialogs and graphFileName as a folder name. If you remember from our files and folder structure, we'll be having our global folder, which will be used for our ungrouped dialogues, and our groups folder, which will be used both for our groups and their dialogues, which are the grouped dialogues. So type in CreateFolder with containerFolderPath as a path and global as a folder name. Do the same but for our groups folder. Then inside of our global folder we can create the dialogues folder right away, as it's a static folder. So type in CreateFolder, interpolated string, containerFolderPath between curly brackets, @global, and dialogues for the folder name. We have all of our static methods created. With that out of the way, we can start by getting our GraphView elements and placing them into their own lists. So in our save method, call in a new method which I'll name GetElementsFromGraphView. I'll make it part of a new region named FetchMethods. I don't really know a good name for this region, so feel free to name it however you'd like. Because we'll need to iterate to the graphElements, we'll be needing a reference to the GraphView. So above in our variables, create a new private static variable of type DSGraphView, to which I'll name GraphView. Don't forget to import the Windows namespace. Then pass in a new parameter to our Initialize method of type DSGraphView, and I'll name it DSGraphView. When that's done, simply set the GraphView variable value to this new parameter. Back to our GetElementsFromGraphView method, we are now able to iterate through our graphElements. So type in graphview.graphElements, and because this variable is of type uQueryState, we'll need to use it for each method. So type in .forEach and pass in graphElement as a callback parameter name. Inside the callback, we'll simply have to cast the element into a node or a group depending on its type, and add it to the corresponding groups or nodes list. And to do that, we'll first need to create them. Start by importing the elements namespace. Then in our variables, create a new private static list of tsGroup, and I'll name it groups. Do the same for our nodes. So private static list of tsNode, and I'll name it nodes. When that's done, initialize both lists in the Initialize method. Back in our GetElementsFromGraphView method, we'll start by checking if the element is of type tsNode. So type in if graphElement is tsNode. I'll use the pattern matching here, so I'll type in node after our tsNode. Then we simply pass this node into the nodes list, so nodes.add and pass in node. Don't forget to return. For our groups, we'll be using the getType instead, so create a new variable outside of the loop of type type, to which I'll name groupType, and assign the value of type of tsGroup. Then inside of our loop, type in if graphElement.getType equals groupType, and this side we'll create a new variable of type tsGroup, to which I'll name group, and assign the casted graphElement variable to it. When that's done, add the group to the groups list through the add method. At the end, simply return. We now have our elements in their corresponding lists, so we can iterate through them to create the necessary assets. We'll start by creating both the graph and the containerScriptableObjects first, as they will be necessary in our SaveGroups and SaveNodes methods. We'll of course be creating assets multiple times, so we'll need to create our own method to be able to reuse it properly. To do that, call in CreateAsset. I'll make it part of the utility methods version. To create our assets, we'll be using the Scriptable Object createInstance method that Unity provides to instantiate our scriptable object. With that SO instance, we'll then use the asset database createAsset method to create an actual asset in our project. Of course, we'll need to know what type of scriptable object we'll want to instantiate, and to do that, we'll be accepting a generic type in our method. We can do that by typing in t between angle brackets after the method name. This simply means we can now pass in any type for this method between angle brackets, which can then be used as an actual type by using the t as a type. You can of course name the generic type whatever you want. I have named it t because it's a common name for generic values. However, we'll be using this t type for our scriptable object instance. That's a problem because Unity's createInstance method needs a type that's of type scriptable object. So we'll have to somehow tell our method that our t type can be any type as long as that type inherits from the scriptable object class. Thankfully, we can easily do that by typing in where t column scriptable object right after our method signature. If you check the createInstance method, this is what it uses. Because we'll be returning the created asset from the method, we need to make sure to update our void return type with t instead. We can now create any type of scriptable object, so create a new variable of type t, which I'll name asset. We'll be instantiating the SO to this variable, so type in equals to scriptableObject.createInstance, passing in t between angle brackets. We now have our SO instance, so we just need to make sure an asset of its type is created in our project folder. To do that, type in asset database.createAsset and pass in asset for the first parameter. For the second parameter, we need to send in the path of where we want to create the asset in, together with the name of the asset file and its file type. To do that, we'll be adding in two new parameters in our method. The first one will be of type string, and I'll name it path. The second one will be of type string as well, and I'll name it asset name. With that done, we'll be creating a new variable of type string, which I'll name fullPath. Then assign it an interpolated string with a path of path at asset name dot asset. The dot asset is simply the file type that assets use. When that's done, pass this variable as our createAsset second parameter. Our SO is instantiated and its asset is created, so we can now simply return it at the end. There is one last thing we need to keep in mind though. If the asset exists, we can simply load it instead of creating a new one. This is not really necessary, but makes it so we don't instantiate the SO again, nor remove and create a new asset. We'll be using the asset database loadAsset.path method to do this. So remove the type of where we declared our asset variable and declare it again above. Then assign to this variable asset database.loadAsset.path and pass in fullPath as a parameter. We don't need to send in the type of the asset we want to load, as this method tries to get the first asset of a type in the path we've sent in, which is also why we've sent in the full path with the asset name included. We can do that in two different ways. We either pass in type of t as a second parameter, in which we'll then need to cast the returned value to t, or pass in t between angle brackets after the method name, which automatically casts it to t. This method accepts both, but I'll go with the second one, so type in t between angle brackets. Of course, right now it's always loading and then instantiating and creating the asset again. So we'll add the other two lines inside an if statement that checks if asset equals null, as that's what the method returns if the asset can't be loaded. With that method done, we can now create a scriptable object asset anywhere we want. In our save method, we'll start by creating our graph and container scriptable objects. To do that, we'll need to first import both the data.save and the scriptable objects namespaces. When that's done, back in our save method, create a new variable before our existing createAsset call of type dsGraphSaveDataSO, to which I'll name graphData. Then pass in dsGraphSaveDataSO as the type of the asset. For our path, pass in assets @editor @dialogue_system @graphs. Again, do not pass in / at the end of the path. For our asset name, we'll pass in an interpolated string with the graphFileName variable and graph after the variable. This is simply to attach graph to the end of the filename. If you don't want that, feel free to remove the whole interpolated string and simply pass in graphFileName. We'll then initialize the graph data by typing in graphData.initialize and pass in graphFileName as the filename argument. With this, our graphSO is now created and its variables are initialized. Next is our dialog container, so type in dsDialogContainerSO and I'll name it dialog container. Then create its asset by typing in createAsset of type dsDialogContainerSO, and because this will be our runtime part SO, we can use the containerFolderPath variable we've created before for our path. Then we pass in graphFileName for the asset name. When that's done, initialize it by typing in dialogContainer.initialize and pass in graphFileName as the filename argument. We can now start saving our groups and nodes. Of course, as we've previously said, we'll start with our groups. To do that, call in a new method we'll be creating named SaveGroups. Pass the graph data and the dialog container as arguments. I'll place it in a new region named Groups inside of the Save methods region. We'll be iterating through the groups list and save each one to the graphSO and then create their scriptable objects, saving them to the dialog container as well. So type in, for each, dsGroup group in groups. And we'll be calling in a new method named SaveGroupToGraph, in which we'll pass in the group and the graph data. For our graph, we simply need to save our group data into a variable and add it to the graphSO groups variable. So type in dsGroupSaveData and I'll name it groupData and call its constructor. We'll be setting its values through the object initializer. So id equals to group.id, name equals to group.title, and position equals to group.getPosition .position, as the previous gets direct. Then add this variable to the graph data groups list by typing in graphData.groups.add and pass in group data. That's it for the graph data. So for our dialog container and SO assets, back in our SaveGroups loop, call in another method we'll create named SaveGroupToScriptableObject. Pass in group and dialog container as arguments. I'll place it under our SaveGroupToGraph method. We'll be taking care about the group folder, SO and dialog container groups dictionary element here. We'll start by creating our group folder, in which you need to know the group name. So create a new variable of type string and I'll name it group name. Then assign the group.title variable value into it. To create the folder, simply type in CreateFolder, interpolate a string @containerFolderPath @groups, and pass in group name as the folder name. We'll also be creating this group folder dialogues folder right away, so that we don't need to do it when iterating through the nodes. So type in CreateFolder with an interpolated string, containerFolderPath @groups @group name, and pass in dialogues as the folder name. With our folders done, we can now create our group asset file. To do that, type in DSIOUtility to which I'll name dialog group and assign to it CreateAsset of type DSIOUtility. For the path, we'll pass in the same path as our second CreateFolder path, so copy it up and paste it here. For the asset name, we'll pass in the group name variable. With our group asset created, initialize it by typing in dialogGroup.initialize and pass in group name. All that's left is to add the group to the dialog container groups dictionary, so type in dialogcontainer.dialoggroups.add and pass in dialog group for the key and a new empty list of DSIOUtility for the value. The dialogues for this group will be added as we are iterating through the nodes whenever they belong to this group. That's it for our group. However, there is one thing we need to keep in mind. We have been creating assets, but we haven't really been saving them. Whenever we update the data of an asset, we need to tell Unity to set that asset as dirty, simply meaning this asset has been updated and needs to be saved. But for these assets to be saved after telling Unity to set them as dirty, we supposedly need to manually save the project. Thankfully, the asset database class provides us both with the SaveAssets method, which saves the changes from code without us needing to manually save the project, and the refresh method, which then imports those changed assets. I say supposedly because I recently tried it with the dirty part only and the assets were created. But I also remember when I first made this system that not having the three method calls will sometimes not create the assets, so we'll add them all to be completely safe. So to do that, call in a new method we'll be creating named SaveAsset. We'll be passing in our dialog group into this method. I'll make it part of the utility methods region. To set our asset as dirty, we'll need to use the EditorUtility setDirty method. However, that method requires an argument of type object, so make sure you update our SaveAsset parameter to be of type UnityEngine.Object instead. We'll be specifying UnityEngine here because the system also has an object type. Update parameter name to be asset as well. Then call in EditorUtility.setDirty and pass in asset. Once that's done, call in AssetDatabase.SaveAsset and AssetDatabase.refresh just under that. Our SaveAsset method is done, so all that's left is to call it whenever we create our assets. That's already done in our SaveGroupToScriptableObject method. So back in our save method, we'll need to do it for both of our assets. So under everything else, type in SaveAsset, graphData, and SaveAsset dialog container. We are now saving all of our current assets and our group saving is also done. With that, it's time for us to start saving our nodes. So right under our SaveGroups method, call in a new method we'll create named SaveNodes. Pass in graphData and dialog container as arguments. I'll place it in a new region named Nodes right under our groups region. We'll start by looping through our nodes, much like we did for our groups. So type in for each DSNode node in nodes. Inside the loop, call in a new method we'll create named SaveNodeToGraph and pass in node as the first argument and graphData as the second. We'll do what we did in our group but for our node data, so create a new variable of type DSNodeSaveData to which I'll name nodeData, and call its constructor together with the object initializer. We'll be setting all the variables. If you are using Visual Studio, you can see them by pressing Ctrl Space. We'll set the ID first to be node.id, then the name to be node.dialogueName, the choices to be node.choices, the text to be node.text, the group ID to be node.group.id, the dialog type to be node.dialogType, and the position to be node.getPosition. We can now add our data to the GraphNodes list by typing in graphdata.nodes.add and pass in node data. Our data is almost done, but we currently have 3 slight problems. The first one is regarding the node group ID. This is simply because our group variable can be null, which means it will throw an error if we were to access its ID variable when that's the case. Thankfully, we can use something handy called null condition operator for member access. This is as simple as adding a question mark after our group and before our dot. If the group is null, then it will simply return null without trying to access the ID variable. If the group is null, then it will simply return the ID variable value. The second one are our choices. Right now we are sending in our node.choices variable. While this might be fine at first glance, we need to keep in mind that we are sending in a list. This is a problem because a list is of reference type, as it is a class. This simply means that the moment we update one of the choices in our graph nodes, our scriptable object choice data will also be updated, as it's referenced in the node choices list. We of course don't want that, and want them to be independent, as changes should only happen whenever we save the graph. To fix this problem, we'll have to clone our list in a way that the clone doesn't reference the original list. There are 2 ways we could do that. The first one is by passing our list into the new list constructor. This will clone the list without referencing it. However, that is only true for primitive types, like strings or integers, as they are value types. For cases like ours, where we are using reference types, we'll need to iterate through the original list, create a new variable of the same type, set its values to be the same, and then add the variable into the new list. So above our node data variable, create a new list of DSIOUtility saved data, which I'll name choices, and initialize it. Then iterate to the node choices by typing in, for each DSIOUtility saved data, choice in node.choices. Inside this loop, create a new variable of type DSIOUtility saved data, which I'll name choiceData, and call its constructor together with the object initializer. We'll then set the text to be choice.text and the node ID to be choice.nodeID. These are both strings, which are value types, so we won't have any problems regarding references. When that's done, add the choice data to the choices list through the add method. We now have our cloned list, so we can swap our node choices below with choices instead. With that done, our data choices shall now be independent of the graph node choices. The third one is regarding our node text. Because we haven't added a callback to our node text field, it will always remain text, no matter how much of the text we change. So go to our DSNode script, and in the draw method in our text field, pass in null for the label, and then a new callback, which I'll name callback. And simply set the text variable to be equal to callback.newValue. Our node text will now be correctly updated. With that done, we can go back to our DSIOUtility class. We do also need to do the same for our node text, as its text field currently holds no callback. So add to the DS multiple choice node script, and at the bottom in our choice text field, we'll be adding a new callback by passing in null to the label and a new callback named callback. Then update the choiceData.text to be callback.newValue. Remember that this choice data is a reference to the choices list element, so updating this will update the choices list element as well. We'll now save our node as Scriptable Objects. So under our SaveNodeToGraph method call in a new method we'll create named SaveNodeToScriptableObject, and pass in node and dialog container as arguments. I'll place this method under our SaveNodeToGraph method. This will be a bit different from the group method, as we'll need to create a node into a different path and a different dialog container variable depending on whether the node is an ungrouped node or a grouped node. We'll do that by creating the SO variable and only initialize it when we know what type of node it is. So type in DSIOUtility and I'll name it Dialog. Then we'll do our if check statement to see if this node is a grouped node. So type in if node.group different than null, and inside we'll need to create this asset in the correct group folder. So type in dialog equals to createAsset of type DSIOUtility, and in an interpolated string we'll give it the path of containerFolderPath at groups at node.group.title at dialogues, passing in node.dialogName as the asset name. All that's left in this if statement is to add the dialog to the dialog container dialogGroups dictionary. So type in dialog container.dialogGroups.add. However, you might have noticed we have a problem here. The problem is that the key of this dictionary is a reference to the group Scriptable Object, which we currently have no way of getting. We'll fix that in a simple way. We'll create a dictionary of every created group SO in which the key will be the group ID, so that we can use the node group variable to get the element, and the value will be the actual Scriptable object. So in our variables above, create a new private static dictionary, as we don't really need it to be a serializable dictionary, and I'll make the key type be string and the value type to be DSIOUtility. I'll name it createdDialogueGroups. Then initialize this dictionary in the Initialize method. We'll now add our createdDialogueGroups scriptable objects to this dictionary. So in our SaveGroupToScriptableObject method, right after we initialize the dialog group, type in createdDialogueGroups.add and pass in group.id as the key and dialog group as the value. With that done, back to our SaveNodeToScriptableObject method, we can add the correct key in our add method by typing in createdDialogueGroups at the key of node.group.id, which gets the dialog group SO with the given group ID. We should of course add our node into this element list, so pass in dialog. You might have noticed we have a few problems here. The first one is that this dictionary value is a list. The second one is that this is not how you add a value to that list, but instead how you add a new element to the dictionary. The third problem is that we need to know if the dictionary already has an element with this key. This is so we can know whether we should add a new element or just update the existing one, which will be adding our dialog to the existing element list. In this dictionary case, we already know it has an element with this group ID as the key, as we've previously iterated through our groups and added an element into it. However, just so we don't really need to think about that, we'll be creating our own utility method that takes care of that logic for us. So in Unity, in our non-editor utilities folder, create a new C# script to which I'll name CollectionUtility. Inside, remove the default methods together with the monobehavior inheritance. I'll make it part of the utility subnamespace. I'll make the class static as well. For our method, we'll create a new public static void method to which I'll call addItem. This method will accept two generic types, K and V. The K will be the dictionary key type, while the V will be the list type, which is a dictionary value. As parameters, pass in this serializable dictionary, as we'll be using this method in our serializable dictionaries, with the type of K and the value of list of V. I'll name it serializable dictionary. As the second parameter, we'll have key. As the third, we'll have value. We'll start by checking if the dictionary contains an element with the key. So type in if serializedFoldDictionary.contains_key and pass in key. Then add the value to the list by typing in serializedFoldDictionary@the_key of key.add and pass in the value. At the end, simply return. If our dictionary doesn't contain this key, we'll need to add a new element to it, in which the element list will only have one value, which will be the value we've passed in. So type in serializedFoldDictionary.add and pass in key as key and a new list of v in which we'll pass in our value as the only element in this list between curly brackets. This is called CollectionInitializer and allows you to initialize a list with certain values in it. You don't really need to type in the parentheses if you don't want to, as they are optional. With this method done, we now don't need to care whether the dictionary already has an element or not, as it takes care of that logic for us. So back in our DSIOUtility script, swap the add method with addItem instead. We don't need to import utility's namespace as our DSIOUtility is already part of that namespace. With that done, we can now do the UngroupedNode if statement. Of course, we can easily do that by typing in else instead of a new if. In here, we'll create the asset in the global dialogues folder. So type in dialog equals createAsset of type DSDialogSO and pass in the path in an interpolated string of containerFolderPath @global@dialogues with node.dialogName as the asset name. Then we simply add it to the container ungrouped dialogues list by typing in dialogContainer.ungroupedDialogues.add and pass in dialog. Our node asset is now created, whether it is an ungrouped node or a grouped node. So with that out of our way, under our if-else statement, initialize the dialog by typing in dialog.initialize. As arguments, we'll pass in node.dialogName, node.text, new list of choices for now, node.dialogType, and false for now as well. There are two things we should keep in mind. The first one is that our node choice data and our dialog choice data use different classes. This is because in our dialog choice data, our node or next dialog is an actual reference to the dialog scriptable object, which in our node choice data, it is simply its ID. Because of that, we'll need to convert our node choices list into a suitable dialog choices list. The second one is that we don't yet have a way to know whether a node is a starting node or not. We'll be creating a method in our node class that returns us that information. Let's start with the first one. So swap the list initialization with a new method we'll create named ConvertNodeChoicesToDialogueChoices and pass in node.choices as an argument. Rename the choices parameter to be nodeChoices instead. Inside, we'll have to iterate through the node choices and add them to a new list with the correct type. So type in list of type DSDialogChoicesData, to which I'll name DialogChoices and initialize it. Then type in for each DSChoiceSaveData node choice in node choices. Inside of our loop, we'll create a new variable of type DSDialogChoiceData, to which I'll name ChoiceData, and call its constructor together with the object initializer. The only thing we need to pass in here is the text, to which we'll assign the nodeChoice.text. We won't pass in the next node reference here, as we'll be doing that when updating the node connections. Then add the choice data to the dialog choices list using the add method. At the end, simply return the dialog choices list. With our conversion method done, we can create our node method. So go to our DSNode script and in the utility methods region, just above our arrow style methods, create a new public method that returns bool and which I'll name IsStartingNode. To know if our node is a starting node is quite simple. If the node does not have a connection in its input port, then it is a starting node. So all you need to do is to get that input port and return its connection variable. To do that, type in port input port equals to input container.children, and we'll be using the link namespace here for a method named first, which simply returns the first element of a high enumerable. So type in .first and import the namespace. We can't really just get the first index because children returns an I enumerable as well. Note that first will throw an exception if it can find any element. If you did want it to return null instead, you will need to use the first or default method. However, because we know there is always an input port in our input container, we are safe using the first method. Then simply return input port.connected. Of course, our method shall return true if the node is a starting node, which means the node isn't connected, so we need to add a not operator at beginning. When that's done, go back to our DSIOUtility script and swap our false value with node.isStartingNode instead. All that's left for this method is to save the dialog asset, so type in SaveAsset.Dialog. We are done saving our groups and nodes to both the graph and the respective runtime part scriptable objects. However, there are a few things left for us to do. We need to set the DialogChoicesConnection to reference the respective dialog scriptable objects, as well as remove the unused groups and node files and folders. We'll start by updating our ChoicesConnections. To do that, in our SaveNodes method, right after the loop, call in a new method we'll be creating named UpdateDialoguesChoicesConnections. I'll place it under our ConvertNodeChoicesToDialogueChoices method. If you remember correctly, I've said I will explain why are we only saving our connections now. When I first started making this system, I've tried the following approach. When iterating through the nodes, if the current node had a connection, then I will create that connection node first. This is simply because when setting the connections, if the next node wasn't created yet, we won't have a reference to it. This was fine because we'll just basically go until the last connected node and then create them in the opposite order. Of course, if we iterated through a node we had already created, we will simply skip that node and its connections. The problem with this approach was when the next node was connected to the previous node. This will get into an infinite loop, as the nodes will always have a next connection. There are possible ways of fixing this problem, but instead I've decided to just go with a simpler approach instead. Our first node iteration is to create the respective dialog scriptable objects. As we are creating those scriptable objects, we'll also be adding them into a dictionary, much like our createdDialogueGroups dictionary. Then we will make a second node iteration that also holds the node respective dialog scriptable object that we can get from our dictionary by using the node ID, and then iterate through each of the node choices. In that node choices iteration, we will get a dictionary value that has a choice node ID as the key and set the dialog SO next dialog value on the current choice to be that dictionary value. Once we update all that we need, we'll then simply need to save our asset. So start this off by typing in for each dsnode node in nodes, and we'll be needing our createdDialogues, so let's create a new variable above by typing in private static dictionary with the key of string for the ID and a value type of dsDialogSO for the corresponding SO. I'll name it createdDialogues. When that's done, initialize the list in the Initialize method. We now need to add our dialog SOs to this dictionary. So in our SaveNodeToScriptableObject method, after we initialize our dialog, type in createdDialogues.add node.id for the key and dialog for the value. Back to our UpdateDialoguesChoicesConnections method, we'll create a new variable of type DSIOUtility, which shall name dialog, and get the respective node dialog SO by assigning createdDialogues at the key of node.id. We'll now iterate through the node choices using a for loop. This is because our node and our dialog choices are ordered the same, so we can use the index from the for loop to access the current choice of both variables. So type in for int choiceIndex equals 0, choiceIndex less than node.choices.count ++ choiceIndex. You are free to place a ++ after the choice index if you prefer, as it doesn't really matter here. Inside, create a new variable of type DSChoiceSaveData, which shall name nodeChoice, and assign the node.choices at the index of choiceIndex value into it. From that, we have our node choice. So the next thing we'll do is actually check if its node ID variable is empty, as if it is empty, then we don't really want to connect this choice with anything. So if string.isNull or empty nodeChoice.nodeID, and if that's true, we can continue to the next choice. In case there is an ID, we'll update the dialog SO choice by typing in dialog.choices at the index of choiceIndex.nextDialog equals to createdDialogues at the key of nodeChoice.nodeID. When that's done, we need to call in SaveAsset dialog at the end of the loop, as the asset was just updated. Our connections are now updated, so all that's left to do is to remove the unused files and folders. We'll start by removing our unused group assets, so in our SaveGroups method, call in a new method at the bottom to which I'll name UpdateOldGroups, and pass in graphData as an argument. I'll place this method under all the other group methods. The way we'll be removing the unused files and folders will be quite simple. We have a list of the old group names, and we'll have a list of the current group names. Whatever old group name isn't in the current group names list should be deleted. So in our method, accept a new parameter of type listOfStrings, which shall name current group names. We are now accepting the current group names list, but we don't really have that list anywhere. We'll actually get a list in our SaveGroups method. So in there, create a new list of strings, to which shall name group names, and initialize it. Then at the end of our for each loop, type in groupNames.add and pass in group.title. When that's done, we simply pass this list to our UpdateOldGroups method call. Back in our UpdateOldGroups method, we can start removing the old groups if there is any to be removed. So start things off by typing in if graphData.oldGroupNames different than null, which means the list is initialized, and graphData.oldGroupNames.count different than 0, which means there is at least one name in the list. With these two checks passing, we can remove our assets. To get the names that are different between the two lists, we'll be using the link namespace except method. This method receives two lists and returns every element of the first list except the ones that are also in the second list. So let's create a new list of strings to which I'll name groups to remove and assign graphData.oldGroupNames.accept the current group names. Make sure you import the link namespace. You'll also need to type in .toList at the end because the accept method returns an IEnumerable. All that's left now is to remove the group assets, so iterate through them by typing in for each string group to remove in groups to remove. And you'll actually be removing the whole folder. This is because this group is no longer in the graph, and even if the nodes of this group still are in the graph, because they will be created again in another folder, we don't really need to care about what's inside of this group folder. To do that, we'll be using a new method we'll create named RemoveFolder. We'll be passing in the path of the folder as an argument, so type in interpolated string containerFolderPath @groups @group to remove. I'll place this method in the utility methods region right under the createFolder method. Update parameter name to be full path instead. You could separate this into path and folder name if you'd prefer. We'll be using the FileUtil class delete file or directory method to remove our folder. So type in FileUtil.delete file or directory and pass in our full path. However, this method actually requires you to add a slash at the end of the path. To be consistent with the other methods, I'll just make this an interpolated string. I'll make the full path be between curly brackets and add a slash at the end. We'll also need to make sure we remove the .meta file. This is because if we don't, Unity will create this folder for us automatically when we go to the editor. So above our first removal, simply copy and paste the same line and swap the slash with .meta instead. Back in our UpdateOldGroups method, we are now removing our group folder. All that's left to do is to update the oldGroupNames variable to have the same names as the current group names. So after our if check statement, type in graphData.oldGroupNames equals new list of strings and pass in current group names to the list constructor. We are not assigning the current group names right away because list is of reference type. We can pass it into the constructor because string is a primitive type, so it's a value type. Our group assets are now updated, so we can start doing the same for our nodes. In our SaveNodes method, call in a new method we'll be creating at bottom named UpdateOldUngroupedNodes. You'll be needing a list of the names to send in as arguments, so create a new list above of type string, and I'll name it Ungrouped Node Names. Don't forget to initialize the list. Then at the end of the nodes loop, type in UngroupedNodeNames.add and pass in node.dialogueName. Pass this list and the graph data to the method. I'll place the method under all the other node methods. Update the first parameter name to be current and grouped node names. We'll basically do the same as in our groups but remove an asset instead of a folder. So type in if graphData.oldUngroupedNodeNames different than null and graphData.oldUngroupedNodeNames.count different than 0. We can then create a new list of strings to which I'll name nodes to remove and assign graphData.oldUngroupedNodeNames.accept current and grouped node names .toList. Then iterate through the nodes by typing in for each string node to remove in nodes to remove. We'll be removing a node asset here, so we first need our own RemoveAsset method. So type in RemoveAsset and pass in the path as the first parameter. So interpolate a string containerFolderPath @global @dialogues and the asset name as the second parameter. So node to remove. I'll make this method be under our createAsset method in the utility methods region. Update the parameter names to be path and asset name. We'll be using the asset database delete asset method to delete the asset. So type in asset database.delete asset, interpolate a string @path @asset name .asset. It is now being removed. So back to our UpdateOldUngroupedNodes method, the only thing left to do is to update the graph data variable. So graphData.oldUngroupedNodeNames equals to new list of strings and pass in current ungrouped node names to the constructor. With that done, we need to do the same for our grouped nodes. So above our UpdateOldUngroupedNodes method call, type in UpdateOldGroupedNodes. We'll be needing two parameters here as well. So create a new serializable dictionary above, to which the key type will be string and the value type will be list of strings. The key will be the name of the group the nodes belong to, while the value will be the list of nodes that belong to the group. I'll name it grouped node names and initialize it. In our for each loop, before we add a node to the dictionary, we need to check if the node belongs to a group. So if node.group different than null, we can then add it by typing in grouped node names dot add item and pass in node.group.title as the key and node.dialogName as the value. Remember to use the add item method we created previously. We then continue to the next element, as to not add a node as an ungrouped node. Pass in group node names and graph data to the method. I'll place this method above our UpdateOldUngroupedNodes method. Rename the first parameter to current group node names instead. Then type in if graphData.oldGroupNodeNames different than null and graphData.oldGroupNodeNames.count different than 0. This one will be a bit different because we are talking about a dictionary. While previously we had a list of node names in one variable, here we have a list of nodes per element in the dictionary. This is because there are multiple groups and each one of those groups can have grouped nodes. So iterate to the dictionary by typing in for each key value pair, string, and list of strings, old grouped node in graphData.oldGroupedNodeNames. Inside we'll be doing what we did in the other methods. We'll get the current dictionary element list value which shows these group node names, except the current group node names. To do that, first create a list of strings and I'll name it nodes to remove, and then initialize it. We will however only remove the nodes if the old dictionary key exists in the current dictionary. This is because when we deleted the group assets, we deleted the whole folder, so our nodes were deleted with it. This means that if we already deleted a group, which means its name isn't part of the current dictionary, its nodes were already deleted. So type in if current group node names dot contains key old grouped node dot key. And this simply means that the current old group we are at is still in the graph, so its folder wasn't removed. Then we can set our nodes to remove to be equals to oldGroupNode.value, which gets the oldGroupNodes list .accept and will be getting the current group node names at the key of oldGroupNode.key, as that gets the current group nodes list for the element with the same group key. And then type in .toList. Under our if statement, we can now iterate through the nodes to remove list, so for each string node to remove, in nodes to remove, and inside remove the asset by typing in RemoveAsset, interpolate a string, containerFolderPath, @groups, @oldGroupNode.key, @dialogues, and pass in node to remove as the asset name. When that's done, set the graphData.oldGroupNodeNames to be a new serializable dictionary with the current group node names dictionary as an argument of the constructor. With this, our same method is now done. The only thing left to do is to call it somewhere. We'll be doing that in our toolbar Save button. So go to the DS Editor window script, and in our Add Toolbar method in the Save button, add an empty callback and call in a method we'll be creating named Save. I'll add this method to a new region I'll name Toolbar Actions, just under the Addition Methods region. We'll start by initializing the utility, so type in DSIOUtility.initialize, and we'll need to pass in both the GraphView and the graphFileName. We don't really have a reference for our GraphView here, so let's create a new variable above by typing in private DSGraphView, and I'll name it GraphView. Then in the addGraphView method, remove the GraphView variable type. We can now pass it in to our DSIOUtility initialize method. For our graph file name, we simply pass in FileNameTextField.value. Once our utility is initialized, we call in our save method by typing in DSIOUtility.save. We are now saving our graph and it should work. Before we do that though, we have a problem. Right now we can save the graph if its file name is empty. Of course, that shouldn't be possible, so whenever we try to save the graph with an empty name, we'll throw in an error dialog saying that we cannot save. To do that, type in at the top of our method if string.isNull/empty FileNameTextField.value, and inside we'll display the message by typing in EditorUtility.displayDialog, which is a method Unity provides to display a dialog window. For the title, pass in invalid filename. For the message, I'll pass in please ensure the filename you've typed in is valid. For the third text, I'll pass in Roger. The third one is simply the text that the OK button will show. Return at the end of this if statement so that our graph doesn't get saved. Because of this problem, we also found another. Our elements can also have empty names. We'll fix that by updating our repeatedNameSAmount property so that the save button gets enabled or disabled depending on the amount of empty names in the graph. So let's start by going to our DSNode script, and in the dialog name text field callback, right after updating the value, type in if string is null or empty target.value. This means that the current value we've typed in is empty, so we'll need to increment 1 to the errors. Of course, we only want to do that if the previous value was not empty. This is because we can add as many spaces as we want, and it will count as the value being changed, as we are only removing the white spaces inside of the callback. So type in if not string is null or empty dialog name, as right now the dialog name has the old value. Then type in ++graphView.repeatedNameSAmount. For our opposite case, type in else, which means the current value isn't empty, and we'll be decrementing 1 to the errors if the previous value was empty. So if string is null or empty dialog name, and inside type in --graphView.repeatedNameSAmount. You can use the callback.previousValue variable if you prefer, but remember to remove white spaces and special characters. All that's left now is our group element, so copy the current code and go to the DSGraphView script to our ungroup renamed callback. Paste the code right after assigning the group title. In here, simply swap the target.value with DSGroup.title, and the dialog name with DSGroup.holdTitle instead. Of course, remove the graphView.variable from the repeatedNameSAmount property. I'll also rename this property to be nameErrorsAmount instead. Of course, rename the private variable as well. If we now save it all and go to Unity, we should be able to save our graph. If we were to remove the graph file name and save, our dialog window should show up. Having no name in the elements should also disable the save button. Do note that when removing the whole text from the group, it will be harder to rename it, and it won't show what you are typing in when renaming it. But it is indeed renaming. If we were to add elements to the graph, pressing in our Save button should create the necessary folders and files. Deleting elements should also remove their assets accordingly.